Okay, so in this video we're going to have a look at intersecting graphs. Now there's quite a lot of skills that you need in order to access these questions, and we're going to build ourselves up to the type of question that you can see on the screen at the moment. Now in order to do this you're going to need to be pretty clued up on sketching quadratics, cubics and reciprocals. So obviously make sure you've checked them out first. If you haven't already, I'm going to put them at the top of the description so you can get those straight away if you haven't seen them already, or if you're a little bit confused at any point. And as well as that, we're going to have obviously our basic understanding of algebra work from GCSE, so sort of factorising and solving quadratics and things like that. But this is the type of question we're going to try and build up to. I'm going to have a look at our first question now. Okay, so this is going to be our first question. So as always, grab a piece of paper, grab a pen, make some notes. We're going to have a look at how to access these sorts of questions. So it says here, on the same axes, sketch the graphs with equations, and then we have these two equations to draw here. So we've got y equals, we have x brackets x plus 1 brackets x minus 4, and we also have this other graph, y equals 2 over x plus 1. It says to indicate all the points where the curves meet the x-axis, and hence write down the number of real solutions to this equation here. And yeah, as you can see, they've set those two equations equal to each other. Okay, so we have the x with our brackets here, and we have our other graph, 2 over x plus 1 on the right. So we're going to have a look at obviously doing that and drawing these graphs and seeing how we approach them. Now first things first, we need to be aware of the different types of graphs that we could be looking at drawing. Obviously forgetting about straight line graphs for the moment, just thinking about our curves as both of these are, we can have a quadratic, a cubic and a reciprocal. Okay, and there are other graphs as well, but throughout this video they're the main ones that we're going to be focusing on, with a little bit of straight line graphs thrown in there as well. But at each of these points we're either going to have, and I'm going to draw these to the side, we could have a positive quadratic which makes a U shape, or a negative quadratic which makes that N shape. We can have a positive cubic which makes this sort of shape, or a negative cubic where we have a negative x cubed. And then as well as that we can have our reciprocal graphs as well, which depending on how we draw our axes, we can have our positive reciprocal which has a little bit, well, looks a little bit like that, or we can have our negative reciprocal which looks just the other way around in those two. Okay, so we're going to be mainly drawing these 6 graphs here, and obviously as I said you need to make sure that you're happy and aware of these sketches here, so obviously do check out sketching quadratics, cubics and reciprocals in the videos in the description. So let's have a look at this first one then. Now the first graph there, we have 3 x pieces, they're going to be multiplied together. There is the x, there's the x there and the x there, and they're all positive, so that's going to make a positive cubic graph. Now the solutions are given to us in this particular one here because it's already been factorised. So when we've got that one there, we've got the first x at the start, which gives us one of the x interceptions, and that's going to be x equals 0. So I'm just going to write this down. We've got x equals 0 as our solution for that one. We have the x plus 1, okay, and that's going to be x equals negative 1. Okay, remember you just flip the signs, or you just set it equal to 0. Remember if there are any difficult ones, you can just set it equal to 0, so we can say when does x plus 1 equal 0, and then minus the 1 from both sides, we get the x equals negative 1, which is why you can just flip the signs, but don't forget you've got that process there if any more difficult ones come along, which they will. And then we've got the last one there, where x minus 4 in the bracket, and that gives us x equals positive 4. So there's our 3 solutions, and we already know the shape of the graph. It's going to be a positive cubic, so it's going to look like that. So if we start to draw our axes, let's just draw it in. And I'm not going to actually draw this graph just yet, but I am going to put these points where I know it's going to cross over. So we have -1 and 4, and remember it is just a sketch, so it doesn't have to be absolutely perfect. It's more about where it crosses over and the shape of the graph that we're getting correct here. So there we go, I know it needs to be around about that big for the moment. Now we have our other graph there. Now that one below is a reciprocal graph. Whenever you're getting a divide by x, that's going to form a reciprocal graph. Now it's a positive x, so it's a positive reciprocal. So we know in terms of just a little basic idea what it's going to look like. It's going to look something like that. But this one here also has a +1 on there. And hopefully you'll remember that with a +1 at the end, that's going to change the y-intercept. Okay, or in other words, obviously we don't have a y-intercept with our reciprocal graphs, but with a normal graph it changes the y-intercept, it moves it up 1. So in terms of our reciprocal graph here, that is going to move up 1, and if I draw just over the top of my sketch there, it just means it's going to be up a little bit higher. Okay, so it's going to cross through the x-axis in that negative region there. Now in terms of actually drawing this, before I draw the sketch, again I just want to know where it crosses the x-axis, okay, because I don't want to have to redraw my sketch twice. So let's figure out where it crosses the x-axis, and that's easy enough to do because we can just set y equal to 0. Okay, remember that from coordinate geometry. If you ever want to find where a graph crosses the x-axis, just put y equals 0 in. So if we sub that in, let's do that down here, we get 0 equals 2 over x plus 1. And just remember, the reason I'm doing this is because any position on the x-axis, the y-coordinate is 0. So if we sub that in, and now we just need to solve it. Not the nicest one to solve, just because we have a little bit of movement to do. It looks like it should be nice and quick, but we have to minus 1 from both sides. So we get minus 1 is equal to 2 over x. Multiply both sides by x, so we get negative x, or negative 1x equals 2. And then divide by negative 1, and we get x equals negative 2. There we go. So there we are. We know it's going to cross over at x equals negative 2. And I'm going to write that down up there. X equals minus 2. I'm just going to mark that on the graph as well. There we go, minus 2 there. And now we can go about drawing these in because we know where it's going to cross over all these different points. So if I draw the reciprocal in to start with, so my reciprocal is going to look something like this. And the other one on the right there is also moved up, so something like that. Again, it's not perfect, okay, but you just have to draw these as best you can. Just extend that axis there. And there's our first part of drawing the reciprocal. And I didn't have to draw that one first. I could have drawn the cubic first, but as I've just finished that one, we'll draw that one in. Now the second one that we need to draw here is the cubic. And like we said, we already know what it looks like. We've drawn a little sketch of it up here. So it's going to go up through that minus 1, back down through the 0, and then up through the 4. So if we go up to the minus 1, back down through the 0, and then up through the 4, and again I can probably just extend that reciprocal graph a little bit. Again, it is only just a sketch, so you are going to have these little situations where you're drawing them where they don't quite meet, or you haven't quite drawn it big enough, or maybe you've drawn it too small. Okay, so if you do that, obviously just make sure you're always drawing it in a pen with a pencil and ruler, and you can always just rub it out and go again, or just draw a second sketch. Okay, it's all about just a little bit of practice with these and just perfecting your graphs as you draw them. But there we go, there's our sketch. If we actually put this onto a graphing calculator, we'd probably see that it's not perfect. Okay, and these little dips and within that cubic graph could potentially be a lot more stretched out, but as it's only a sketch, we're not going to stress too much about that. And actually we'll have a look at what it looks like in a sec. But before we do that, it says here, hence write down the number of real solutions to the equation, and then what they've done here is they've just set them equal to each other. Now if you remember from GCSE, if you want to solve two sort of graph equations algebraically, all you have to do, as long as they're both y equals, you just set them equal to each other and find the x coordinate, okay, solving them simultaneously, and then you sub the x coordinate back in to find the y coordinate. But this question here has said, hence, obviously using our diagram there, write down the number of real solutions to this equation. It doesn't want the solutions exactly, it just wants to write down how many there are. So as we can see on the graph here, we've got one here where they cross over, and we have another one just there. So in total, we have two solutions as the graph crosses over, the graphs cross over at 2 points there. Okay, so we would obviously just say two solutions as the graphs cross over at 2 points. I'm just going to write that in there, two solutions, and there we go. Okay, so that's the end of our first question. Obviously there was drawing reciprocal graphs, so there's a little bit of graph transformations there as well with the +1 moving it up by 1. And we actually also had drawing a cubic graph, and we had some solving equations. So as you can see, there's a lot of different topics in here, even though once you've got the hang of drawing these, the topic is actually relatively straightforward, okay, once you've done quite a few of them. But you can see there's quite a lot of topics involved here, so do make sure you check out any of those videos on previous topics obviously relating to this. But that's our first question, and before we move on, let's just have a look at what this would look like. Okay, so if you use this app, and it's a great little app to use, it's called Desmos. So all we actually need to do to have a look at that graph there is just type in the equations for these two graphs. And it's a really good tool when you're doing topics like this, just for having a look at what these graphs look like. So if we type them in, we can have y equals x, and then what was it? It was brackets x plus 1, close brackets, and then it was x minus 4 in the other bracket. X minus 4, there we go, and that's going to give us just a little overview, or kind of little look at what it actually looks like. If we put our second graph in then, which was y equals, we had 2 over x, so 2, and we'll put divide by x, there we go, come out of the fraction, and then we'll put the +1 there, and that shows it obviously moving up slightly. Now it's really good look because obviously we can see that our graph wasn't too far off, the reciprocal looked good, and the negative part of the graph on the left there looked good, but obviously this dip was a lot bigger, well, a lot smaller on the sketch that I drew. Okay, but as I said, it is just a sketch, but it's a great little opportunity just to have a look and actually see if your sketch is correct. And as we can see, there's one crossover point just there, and there's another crossover point just there. And as well as that, we can also see where it crosses through the x-axis. We can see the -2 over here that we had. We can see these solutions here, the -1, the 0, and the 4, and we can pretty much check everything that we had on that question. So just a little thing for you to have a look at. It's called Desmos. It's a great little app. You can get it on your phone or on an iPad or on a computer. It doesn't really matter what device you're using. You should be able to access this on anything. So there we go, just a little thing to show you along the way. Let's have a look at our next question. Okay, so for this next question, we have a very similar concept here. It says on the same axes, sketch the graphs with the equations, and it gives us these two equations again. They're very similar. Look, we've got, well, not a triple bracket because we have the x on the outside, but we have another cubic. And we also have another reciprocal, and we've got that minus sign in front of it, so we'll be aware of that in a sec. Now it says indicate all the points where the curves meet the x-axis, and then we've got a second part here which is using your sketch, state giving a reason, the number of real solutions to the equation, and again they've set them equal to each other in a sense, but we'll talk about that a little bit in a sec there. Now obviously we need to draw them, and we just need to think about what they're going to look like. Now on this first one we have a minus x involved there, so just make sure you're careful with that. It is going to make a cubic, but it's going to make a negatively sloping cubic, so it's going to look just like that. And then on the one below we've got a reciprocal, but we've got a minus sign just there. So it is going to make a very similar graph to what we had before, but it's going to be in the other regions just there. Okay, so that's what our two graphs are going to look like as a very basic sketch. Now let's think about where they cross through the axes. So the first one, and again remembering with cubic graphs sometimes we will have the same solution, okay, but obviously we've got three different solutions here for this one. For the first one we have x equals 0. For the second one there we've got x is -2. And for that third one there, which sometimes throws people a little bit, if we just set that equal to 0, 3 minus x equals 0, add the x to the other side, we get 3 equals x, or x equals 3. So there we go, x is +3 for that one. Just sometimes throws people when it's written the other way around there. But there we go, there are our three solutions for the cubic. And for the one below, we have a negative reciprocal there, and it hasn't actually moved up or down or left or right, so that's not even going to cross through the axes at all. Okay, so we don't need to worry about setting that equal to 0, okay, because at the moment it hasn't been moved, so it's never going to touch the axes, as I'm hoping you're happy with there with the reciprocal graphs. So if we draw this in, and let's just, again, we are only drawing a sketch, but I want to make it big enough obviously because we're going to want to go through -2 and +3, so let's just write those in, -2, +3, and 0 it's going to go through. So if we draw the reciprocal in to start with, that's going to look something like that, and something like that, there we go. And now drawing our cubic, and not forgetting it's negatively sloping. So it's going to come down through the -2, up through the 0, and then back down through the 3. So down through -2, back up through the 0, and then down through the 3. And again, I'm going to have to just extend that green line from the reciprocal a little bit there. There we go, so that's drawn. And again, obviously we can highlight the points where they've crossed over. So we've got this one here, and we've also got that one there. So again, it says down below, indicate all the points where the curve meet the axes, which we've done, -2, 0, and 3. And then using our sketch, state given a reason, a number of real solutions to this equation. Now what they've done here is they have set it equal to each other, okay, but what they've actually done is they've added that 2 over x back over to the other side, look. So they've said, okay, well when does x brackets x plus 2, 3 minus x, when does that equal -2 over x? And all they've done, like I said, added the -2 over x over to the other side so that it equals 0. Essentially just saying where do they intersect, okay, they're just solving it simultaneously. So in regards to our question here, we have two solutions. There we go, and it does say giving a reason, so it's just as the curves intersect at 2 points. There we go. There we are. Intersect at 2 points. Okay, there we go. So we've had a look at reciprocals and cubics and different graphs in this one and in terms of how to approach them. So hopefully you're happy with obviously drawing your sketches, and that's how we're going to approach these questions. So we're not going to have a look at a huge amount of these, but just be aware as well that my cubics here, none of them had the double solution where they were the same. So if there is a double 0, for example, or a double 3, and how that affects the curve. So just remember, obviously, and if I draw a little sketch over here, that if you do have two solutions, which you are going to have on this next one, so let's imagine we had something like, I know, let's imagine it's a positive cubic, and there are two solutions maybe at 3, and we also have a 0. Let's imagine something like that. So maybe we have x minus 3 in 2 brackets and x on the outside. That would go up through 0, and the one that has the double solution on it bounces on that one and doesn't cross all the way through. Okay, so don't forget that that can happen as well. And likewise, like the one you're going to see, you could have two x's at the start. So anyway, here's your question to have a go at, and we'll have a quick read through it first. Okay, so this question says the diagram shows a sketch of a curve C with this equation, 1 over x plus 1. So that's a reciprocal graph that's been moved up by 1. And it also gives us this little statement here where it says x is not equal to 0. Okay, and that just indicates one of our asymptotes, okay, the fact that it never crosses through the y-axis, or that line x equals 0. Okay, hopefully we already know that from reciprocal graphs. Now it says, first of all, state the coordinates of A, and that is the point where it crosses through the x-axis, and we've looked at that and how to solve that, okay, what you have to set y equal to. And then on part B it says, on the same axis, sketch the graph with equation y equals x squared brackets x minus 2. Now that's what I was talking about just there. We've got x squared on the outside, so that's two solutions there. You've got x is 0 and another one x is 0, so it's going to bounce on 0. So be thinking about that when you draw this in. And it says indicate where the curves meet the x-axis. Okay, so you've obviously got the reciprocal graph to label and that cubic and where it goes through the x-axis. And then again it says using your sketch state the number of real solutions to the equation, and again it's set them equal to each other. So pause the video there, have a go at this, and we'll go over the answers in a sec. Okay, so for this first one then, first of all I'm going to find that coordinate for A, as that's our first question there, so we just need to set the equation equal to 0. So our equation is 1 over x plus 1, and that's equal to y, so 0 equals 1 over x plus 1. So if we minus the 1 to the other side, we get minus 1 is equal to 1 over x. Multiply the x to the other side, we get negative x, or negative 1x equals 1. And therefore positive x, if we divide by minus 1, we get x equals minus 1. And that makes sense in terms of our diagram as well. That one there is minus 1. That's part A done. We've got x is minus 1, and we want to state the coordinate of that. So as a coordinate, that would be minus 1, 0. Okay, we already knew the y coordinate was 0. So for part B, on the same axis, sketch the graph with this equation. So if we have a look at this equation quickly, the x squared indicates that we have two x solutions there. We've got x is 0 and another x is 0. There we go. And then we have the piece in the bracket, x minus 2, and that gives us x equals positive 2. And again, it is a positive x cubed if we were to expand that, so we would have a positively sloping cubic graph. And it needs to go up to the 0. So you can imagine here's where the bounce on the 0 is going to be, and then in somewhere over here it's going to go through 2. Okay, so I'm just going to mark that 2 on my axes there, and then we're going to try and draw this in as best as we can. Let's just swap colours. So it's going to go up to the 0, bounce back down as there's two solutions there, and then back up through the 2. And again, just drawing a sketch there, so nothing perfect. So there we go, we've drawn it in, and it says using your sketch state the number of real solutions. Well, we have one here where they cross over, and we have another one there where they cross over. And again, it doesn't actually say give a reason this time, but I'll always usually give a reason anyway. So we've got two solutions, and the reason again is because the graphs or the curves cross over at 2 points, or they intersect at 2 points. But there we go, it doesn't actually say give a reason, but we'll talk about it anyway. And we've got two solutions, and there is the answer to our question. Right, okay, so the next part of this process is to actually find the coordinates of those points of intersection, okay? And you should hopefully remember that from GCSE with solving simultaneous equations, although these are going to be quite nice ones where they're both y equals, okay? So we're just going to be able to set them equal to each other like they've done in the second part of this question here that we can see, but we're actually going to go ahead and solve that and find the coordinates. So let's have a look at some of those now. Okay, so for this question it says, on the same axes again, sketch the graphs with these equations. And again, we're going to indicate the points where the graphs meet the x-axis, but here is the new bit now in part B. It says, use algebra to find the coordinates of the points of intersection. So we're going to have a look at doing that. We're going to need to remember some of our algebraic skills from GCSE and a little bit of our algebraic skills that we've learnt, obviously, at AS level, but we're going to have a look at this question. So the first thing to do again is to identify these graphs and what they actually are. So this first one here, look, we've got a minus x at the end. So that is going to be one of our negative cubics. That's very similar to the last one that we looked at in the sense that we have an x squared at the start there. So our 3x coordinates it's going to cross through, we're going to have x equals 0. We've got another x equals 0, which indicates that we're going to have a bounce just on the origin there. And then we have x equals 3 for the last one. And again, just set that equal to 0 and solve it if that one ever throws you there where it's in reverse. The second graph, or the line that we have to draw there, is a linear graph. So it's a straight line, okay, with a negative gradient. That's -4 there. So that's going to be a negatively sloping line. And again, we can find out where it crosses the x-axis because we know the y-intercept, well, it's not there at the end, which means it has a y-intercept of 0, which means it's going to cross through the x-axis at 0 as well as it's going to cross through the origin. So we can go ahead and actually think about drawing these. Now, when it comes to drawing some of them, they're not the nicest to draw, to be honest. It's quite hard to imagine how many points of intersection they're going to have. So you just need to go ahead and have a go at doing your drawing, and sometimes you're going to have to extend it. A little tip maybe is to not fill up your axes when you're actually drawing your sketch, and then if you do need to extend it a little bit, it's not going to really have much effect on you there. So thinking about what this looks like then, it's going to come down, it's going to bounce on the 0. I'm thinking about my little sketch at the top there, that's going to be at this point here. It's going to bounce just on that little dip there, and then it's going to cross through again later on the 3. So if we label that on, let's go with our 3 there, we've got 0 here. So it's going to come down, bounce on the 0, back up, and then back down through the 3. So there's our cubic graph. Now we just need to draw that straight line graph. Now, it's not the nicest of ones to draw, to be honest. Obviously, you want to make sure that you have a ruler and a pencil when you're doing this, but our straight line is going to come down. It's got quite a sharp gradient, but I'm only drawing a sketch. I'm just going to extend it. There we go, and you can see I've probably not drawn that cubic quite big enough. Let's just extend it slightly. There we go, and as you can see, that straight line is going to cross through the cubic there at 3 different points. And I've not really emphasised the fact that it's got quite a steep negative gradient there, more just about making sure it fits on my axes that I've drawn. But as you can see, we've got 1 point here, 1 point here, and another point down there. Now, one of those points is nice and easy for us to find when we're using algebra to find the coordinates, and that's the fact that they both cross through the origin. So we know that one of our solutions is going to be 0, 0. We just need to go ahead and find the other two. So let's have a think about how we do this. Now, we know from the last questions, all we need to do is set them equal to each other. So if I take those two equations, so the first one, which is x squared, brackets 3 minus x, and I'm going to set that equal to the negative 4x. Now all I need to do, just like obviously things we've done at GCSE, I need to make this all equal 0, so I need to get rid of any brackets and get everything on the same side. Now if I do that, so if we expand this first bracket, so timesing 3 and negative x by the x squared, we get 3x squared on our first multiplication, and then minus x cubed for the second one, and that is equal to negative 4x. Now I need to make it all equal 0, and I have a choice. I can either move everything to the left or move it to the right. Now, just to keep this a little bit easier for me to factorise, I'm going to move everything to the right just so that that x cubed is positive. So if I move it to the right, and I'll emphasise that by putting the 0 on the left, we're going to get positive x cubed. We're going to subtract the 3x squared, so minus 3x squared. I'm just putting in the order of the powers there as well. And the minus 4x on the right hand side there isn't going to change. And there we go, there's our cubic, and we just need to factorise this. Now the nice thing about this is obviously there's no number at the end. If there was, we'd have to involve a little bit of extra mathematics here, which we haven't quite covered up to this point, well, I have done a video on it, it's on the factor theorem. If we did have a number at the end, we'd have to apply that. But for the purpose of these questions, we're not going to be looking at the factor theorem, we're just going to be looking at these questions here, where it can be factorised without the use of the factor theorem. So in order to factorise this, we need to take a factor of x out to start with. And if we do that, I'll leave it as 0 equals, we get x brackets, and then dividing all these pieces by x, our x cubed will be an x squared, our minus 3x squared goes down to minus 3x, and our minus 4x goes to minus 4. And as you can see in that bracket now we have our quadratic. And again we just need to factorise that to get our last bracket. And if we think about our factors of 4, that can either be 1 and 4, or 2 and 2. And in order to make negative 3 in the middle, it's definitely going to be 1 and 4. It's going to be positive 1 and negative 4. So our brackets there, and I'll get rid of the 0 equals just for the purpose of this. We have x plus 1, and we have x minus 4. And again, as you can see, our solutions are now within those brackets. Again, we can find those quite nice and easily. Obviously, as this is all equal to 0 still, there we go. And our solutions are, for the first one, we have x is 0, which we have already drawn on just here. For the second one, we're going to have x is negative 1. That's going to be this one up here, so minus 1. We could always mark that down there if we wanted. We just need to obviously find the y coordinate. There we go. And for our last one here, the x minus 4, that's going to be positive 4, which makes sense with our diagram just there. So that's going to be positive 4. There we go. So there's our three solutions. Obviously we just need to find the y coordinates, as we have been asked in the question to find the coordinates, not just the x values. So we just need to sub that into one of the equations to find our y coordinate. And I'm going to go for this second one here, as it's a little bit easier to substitute into. We just need to multiply x by negative 4. So if y equals minus 4x, and when x equals minus 1, y is going to equal negative 4 times that, it'll be positive 4. And when x equals positive 4, multiply that by 4, negative 4, sorry, y is going to equal negative 16. And we can put those coordinates in now. We have minus 1, 4, and positive 4 along with negative 16. And there are our three answers there, negative 1, 4, 0, 0, and 4, negative 16. So we had quite a lot going on there. Obviously we've sketched a straight line graph along with a cubic, being careful obviously to find the points where it crosses the x-axis so we can draw a nice accurate sketch. And then we use them and solve them simultaneously by setting them equal to each other. And obviously we had all this process of factorising the cubic by taking the factor of x out, getting our quadratic and subbing it all in, just like skills that you've done at GCSE there, obviously finding the solutions and subbing them back in to find y. But that is how we're going to approach these questions. Now I've got one more question on this that we're going to have a go at, and then a couple for you to have a go at, and then we've got some challenge questions. So let's have a look at our next one, and let's go for that one now. Okay, so we have a very similar question here. It says on the same axes, sketch the graphs with these equations. And then we have what looks like a cubic in the first one, as if we were to expand that, we would definitely get an x cubed. And we have a quadratic in the second one, as we would get an x squared if we were to expand that one. It says indicate all the points where the curves meet the x-axis, similar to before, and use algebra to find the coordinates of the points of intersection. So again, we're going to just think about what these curves look like. And again, with that first one, if we were to expand that, we'd get an x cubed. That would be a positive x cubed. So that's going to be sloping positively with a cubic graph. And our second one there, if we were to expand that, we'd get a negative x squared. So we have an upside down quadratic, like a little n-shaped quadratic. So that's the shape of our two graphs that we're going to draw here. Again, we just need to find those intersections with the x-axes. So thinking about that first one, we've met one similar to that. We have an x squared at the start. So we have x equals 0, and we have two of those. So we've got a little bounce again on the origin. So we've got x equals 0 for both. And for that bracket there, x minus 3, we're going to get x equals positive 3. There we go. So there are the points where the cubic is going to meet the x-axis. For the next one, we have a quadratic there. It's an upside down one, but again we have x equals 0 for that x on the outside, and x equals positive 8 for the bracket, and again just setting that equal to 0 if you need to for those ones in reverse. So thinking about what this is going to look like then, let's draw it out. All of our solutions there, the points where it crosses the axes, are in the positive region of the x-axis. So I'm going to extend that a little bit more, and we've got 3 and we've got 8. And I'll try and scale it there as best as I can, but there we go, 3 and 8. Now if we draw this in then, obviously it needs to cross over on 0 as well. It is going to come up, it's going to bounce on the 0, and then it's going to go back up and through the 3 for the quadratic there for this 3. So just drawing in the bit that I can there, it's going to come down and then bounce up through the 3. So there's our cubic. Now we just obviously need to draw that quadratic in, and for the purpose of the quadratic I'm going to just swap to a different colour. Let's have a look, and it's going to be an upside down U that goes through the 0, back up and then down and through the 8. And I've not quite perfectly gone through the 8 there, but you get the idea. Now for the purpose of this one, it's not the nicest one to draw, but somewhere down in this region there is a very good chance that they're going to cross over again. Now we're only drawing a sketch, so we don't have to extend that all the way down, because when these two meet they can be very, very low down. But just bear in mind we may get a solution down there when we're solving it, but for the purpose of our sketch we've drawn a pretty good sketch there, and you could extend it and cross them over if you want, but they're not the nicest or the easiest to draw. But we've definitely got one solution here on 0, 0, we've definitely got another one up there somewhere else, and we may have another one down the bottom like I said, but we'll test that out using our algebra to see if we get one. But there we go, we've drawn our graphs, and now it says use algebra to find the coordinates of the points of intersection. So again, we already know one of them. We know 0, 0, so we know one of our solutions is going to come out as 0, but we need to find the other two. So let's have a go at this. Now again, it's the same process. All we do is we set these two equations equal to each other as they are both y equals. So we can say x squared, and in fact let's just expand it out straight away, rather than having extra lines of working out. So x squared times x gives us x cubed, and then x squared times the minus 3 gives us minus 3x squared. And that's going to be equal to, I'm going to expand the other one out, x times 8 is 8x, and then x times x is going to give us the negative x squared there that we mentioned. So there we go. Now we just want to make it all equal 0. So I'm going to move these pieces on the right over to the left to keep the x cubed positive. So we'll have x cubed. We're going to add 1x squared to the negative 3x squared, so that's going to be negative 2x squared, and then we're going to subtract 8x from both sides, so minus 8x, and that all equals 0. There we go. Now from here it's pretty much the same process. Now we know that because we have a cubic here to solve, we know we're going to get 3 solutions, unless of course 2 of them are the same, but I'm going to predict that we're definitely going to have that additional solution that I've highlighted down the bottom just there. But let's take out a factor of x to start with. So we'll get x brackets, and then it'd be x squared minus 2x minus 8, and that all equals 0. There we go. Let's just close the bracket on that quadratic. Now we can factorize that. So 8 at the end is probably going to be 4 and 2 rather than 1 and 8, as we're making negative 2 in the middle. So if it's 4 and 2, we can have x plus 2 and x minus 4. That's going to make negative 2 in the middle. There we go. And that's all equal to 0. Fantastic. So we've got our 3 solutions there. We've got the first one, which gives us our x equals 0 that we already knew. We've got our second bracket there, so we've got x equals minus 2, and we've got the final bracket, x equals positive 4. So there's our 3 solutions. Obviously the 0, 0 we already knew, but we've now identified the positive x coordinate over here, which is 4, which makes sense in between our 3 and 8. And we've got the other one down there that we've highlighted, so we can get rid of that because we've definitely got one down the bottom. And that has an x coordinate of minus 2. So again, we just need to find the y coordinates for these. Again, neither of these are particularly easier than the other to substitute into. I'm going to go with the one with the squared in, so I'm going to substitute into y equals 8x minus x squared. So if y equals 8x minus x squared, and let's just write this up here. There we go, minus x squared. Let's have a look. When x equals 4, we get 32 take away 16, so that's y equals 16. And when x equals negative 2, 8 times negative 2 is negative 16. Take away negative 2 squared, which is 4. We're going to get y equals negative 20. And don't forget, you can obviously type that into your calculator. Just be careful when you're subbing in a negative number, you make sure you put that in a bracket. But there we go, we get minus 2 minus 20. I can just about fit that in the bracket there. And the other one was 4 and 16. So there we go, there's our three coordinates, -2, -20. Obviously -20 would have been quite far down, 0, 0, and then 4, 16. And there's our three coordinates. Right, okay, one for you to have a go at then. Let's have a look at it. Okay, so this question is very similar to the one that I've just gone over. In fact, the graph looks almost identical in a sense, but you have to obviously draw that out and again find the coordinate points. So on the first graph that you have to draw there, look, you have a positive cubic again, and on the second graph you have a negative quadratic. So pause the video there, have a go, see if you can solve this question, and we'll go over the answer in a sec. Okay then, so drawing this out, so if we draw our axes in, and then again we'll have a think about what it looks like. So for that first one there, we've got an x squared at the start, so we've got x equals 0. For the other one, we also have x equals 0, and then in the bracket there, we get x equals -2. And again, that's a positively sloping cubic graph, so that is going to be sloping in this direction, and again with a bounce on the 0. The next one there, we've got x equals 0 again at the start there, and in the bracket we've got x equals +4. And again, that's going to be negatively sloping, so we've got an upside down quadratic there. So on the graph, we know we're going to get a crossover through 0, we know we're going to get a crossover by -2, and we know we're going to get a crossover at 4. So it's going to look ever so slightly different as we have that negative crossover there, but let's have a look at what this is going to look like. So for the first one, the cubic, now it has to go up through the -2 as it's positively sloping, and then we know it's going to bounce on the 0, and then it's going to go back up again. So there we go, there is our cubic graph sketched in. For the next one, we know that it's going to be an upside down quadratic, so we know we're going to have that N shape, and we know that it's going to go through 0 and then back down through 4, so something like that. So again, looking at our solutions here, we know we've got one on the origin, we can see that we've got one there, and potentially we might have one down there as well, which we'll figure out in a sec. So if we go about actually figuring this one out, then we just need to set these equal to each other, and again I'm going to expand those brackets before I set them equal to each other. So x squared times the x gives us our x cubed, x squared times the 2 gives us 2x squared, and that's going to equal 4x minus x squared, again just expanding this little bracket here. Now moving it all to the left hand side again, we get x cubed, and then 2x squared add an x squared gives us 3x squared, and then minus the 4x, and that all equals 0. Okay, so taking out a factor of x again, so take the factor of x out, and what quadratic do we get here? X squared plus 3x minus 4 equals 0. We want to make +3, so inside that quadratic there, that's going to be 1 and 4. So we want to make +3, so we can have x plus 4 and x minus 1. There we go. And we get our three solutions there. We have x equals 0, x equals -4 for the +4 bracket, and x equals 1 for the x minus 1 bracket. And if we have a look at those on our graph, we already knew the 0, 0, so we don't need to worry about subbing that back in. We have the +1 over here, which again we're going to find the y coordinate for, and down the bottom we figured out we definitely have a solution down there, and that is our -4. And again we just need to find the y coordinate. So again, it doesn't matter which one you pick, I'm going to go for the 4x minus x squared. So again we'll work that out up here. So when y equals 4x minus x squared, we've got our 2x coordinates, so when x equals 1, we get 4 take away 1, which is y equals 3, and we can put that in. And when x equals -4, 4 times -4 is -16, take away 16, that leaves us with -32, so y equals -32. There we are, so -4 minus 32 was our second one there, and obviously not forgetting the 0, 0 in the middle. So 1, 3, 0, 0, and -4, -32. Right, okay, now before we have a look at our final two exam style questions that are pretty tough, I've got one more question for you to have a go at, so let's have a go at that one now. Okay, and so for another question for you to have a go at, it says here the diagram shows a sketch of a curve with equation y equals 2 over x where x doesn't equal 0. And again, that's shown to us on the right over there. It's just a normal reciprocal graph. But it then says the curve C has equation y equals 2 over x minus 5. And if you remember, minus 5 there will move it down by 5. It says, and the line L has equation y equals 4x plus 2. It says sketch and clearly label the graphs of C and L on a single diagram showing any coordinates where graphs cross the coordinate axes. For part B, write down the equation of the asymptotes of curve C. So again, obviously linking back to asymptotes in reciprocal graphs, so do make sure you've checked that video out. And then for part C, find the coordinates of the points of intersection for these two graphs. So this is one that I want you to have a go at. So have a go at drawing those graphs. Try and write down obviously the equations of those asymptotes, that's nice and quick, and then also set them equal to each other and try and solve for those intersection points. So again, this is one I want you to have a go at, so pause the video there, have a go, and we'll go over the answer in a sec. Okay then, so for drawing this, now first of all I'm going to draw that reciprocal graph. Now it basically looks the same as the one above, except it's going down by 5. So if I move this left one down, I'm not going to go too far down there, but I'm just going to move it down, okay, there we go, to a certain type of scale, there we go. And for the next one we have a straight line graph, so we have y equals 4x plus 2, so it has a positive gradient and it goes through 2 on the y-intercept. So if we kind of just imagine over here where 2 is, let's just imagine it's just there we go, and our graph is going to pass through that. So it's going to be quite a steep gradient, but I'm not going to worry too much about making it look perfect. Again, it is just a sketch. And let's just extend that reciprocal graph slightly, there we go. So there's our two graphs, and there is our little sketch. It does, however, say show any coordinates where the graph crosses the coordinate axes, and we've already got that 2 there. But there are 2 more points that we need to find. We need to find the x-intercept of the straight line, and we need to find the x-intercept of the reciprocal graph. So again, we can find both of those by setting the equations equal to 0. So if we have a look then, we've got the 2x minus 5. Let's set that equal to 0 first. Sorry, 2 over x minus 5. There we go, so 2 over x minus 5 equals 0. So if we add the 5 to the other side, we get 2 over x equals 5. Multiply the 5 over, the x over to the 5, so we get 2 equals 5x, and then divide both sides by 5, we get x equals 2/5. There we go. So that is the x-intercept of the reciprocal graph. So let's label that on there, 2/5. Now we need to find the x-intercept of the straight line, and again we're just going to use the same process, setting it equal to 0. So let's do that just here. So we have 0 equals 4x plus 2. Minus the 2 to the other side, we get minus 2 equals 4x, and then dividing both sides by 4, we'll get x equals minus a half. There we go, or minus 0.5. And let's label that on minus a half, and there is our sketch completed. Now the next part says write down the equation of the asymptotes of curve C. Now remember, the original asymptotes are x equals 0 and y equals 0, but it has moved down. Now it hasn't gone left and right, so we still have x equals 0 as one of our asymptotes. There we go, it will never cross through x equals 0, but our y equals 0 has moved down. It's moved down 5 places, so we're going to have y equals negative 5 as our second asymptote there. And we could even go about drawing it in, it doesn't ask us to, but just thinking about where that y equals minus 5 is, it goes through here, it's going to go right through my fractions there, so I'm going to try and avoid them. There we go. But that's where our new asymptote goes through, and obviously we still have the same asymptote going down the y-axis there, x equals 0. So there's part B. For part C, we obviously need to find the coordinates of the points of intersection. Now it's quite a lot of working out for this one, so I'm going to have to get rid of some of this working out up here, but in fact we can leave that one in. We'll get rid of all of this working. There we go. And we're going to go and try and work this out. Let's see if I can make this smaller and move that out of the way. Let's just move it up here. There we go. Right, so we need to set these equations equal to each other. Now if we do that, we get 2 over x minus 5 is equal to 4x plus 2. Now there's different ways that you can go about solving this. Either we can move the 5 over, or we could multiply by x straight away. I'm going to add the 5 over to the other side. So we get 2 over x equals 4x plus 7, and then multiply both sides by x, we get 2 equals 4x squared plus 7x, not forgetting to times both those pieces, and then we can minus the 2 over. So 0 equals 4x squared plus 7x minus 2. Now we have our quadratic, so we know that there are going to be 2 solutions, and we can see that on the graph as well. We can see that we had one solution here and one solution up there. So they're the 2 that we're trying to find. So we can kind of see, we know that one of them is going to be negative and one of them is going to be positive as well for those x coordinates. So if we factorize that quadratic, and again it's not too nasty to factorize, it's going to be 4 and 1x in the bracket. Let's have a look. Obviously you could have 2x and 2x, but as we've got a 7 in the middle, we can't have 2 even coefficients of x in the brackets there, otherwise we're never going to make 7. So it has to be 4 and 1. So we're going to have 4x and 1x. There we go. That equals 0. And we're trying to make 2 at the end, so our only factors can be 1 and 2, and we're trying to make 7 in the middle. So if we double the 4 or quadruple the 2, that makes 8, and then 1 over here, and we're going to want to make positive 8 take away 1. So there's our 2x solutions. We've got x is equal to positive 1 divided by 4, so 1/4 for the first one, and x equals negative 2. And obviously not forgetting at this point here, you could obviously use the quadratic formula to avoid having to factorise, but I like to avoid using the calculator wherever possible. So there's our 2 x coordinates, 1/4 and negative 2, and then we just need to sub that into one of the equations to get our y coordinates, and I think the easiest one here is probably the y equals 4x plus 2. So if we sub it into there, when x equals 1/4 or 0.25, y will equal 4 times 1/4 is 1 plus 2 is 3, so y equals 3. For the other one, when x equals negative 2, well, 4 times negative 2 is negative 8, add 2 is negative 6, so y equals negative 6. So we found that this coordinate here is going to be negative 2, negative 6, and the one in the positive region up there is going to be 0.25 or 1/4 and 3. There we go, so there are our 2 coordinates, negative 2, negative 6 and 0.25, 3. So fantastic, that is our final question ready for you to have a go at. What we're going to have a look at now is an exam style question that's a little bit trickier and a little bit more maths involved, but one that you can always have a go at, and obviously we will be going over the answer. So let's have a look at our final question now. Okay, so for our final question here, it says on separate axes, sketch the graphs with these equations, and we have y equals negative 3x plus c, where c is a positive constant. And for our second one there, we've got y equals 1 over x plus 5. It says on the graph, show the coordinates of any points of intersection at which the graph crosses the y-axis and the equation of any horizontal asymptote. It also says here, given that then y equals minus 3x plus c meets the curve at 2 distinct points, show that, and then we've got in brackets 5 minus c squared is bigger than 12, and hence find the range of possible values. So as well as everything that we've already looked at, we've got a couple of other topics getting involved here. We've got some, and again I'm just going to highlight this word here, 2 distinct points. That is indicating to us that we're probably going to have to look at the discriminant. Then we have down here finding the range of possible values for this inequality. So we've also got some quadratic inequalities in here as well. So we've got quite a lot of topics coming into this. But for the first bit there, all you have to do is draw a sketch of what those would look like. Obviously not worrying for your sketch what the y-intercept is, but just drawing it as we have normally, and drawing those on 2 separate graphs this time. But there we go, there's a few little hints and a few little things to have a look at, but I would encourage you obviously just to pause the video, see how much of this question you can do, and then we'll go over the answer in a sec. So if you're going to do that, pause the video there and we'll go over the answers. Okay, so let's have a look at this one then. So drawing these graphs, now the first one we have a straight line graph with a negative gradient. So in terms of what that's going to look like, and if we just draw this to the side, minus 3x plus c, now it does say where c is a positive constant, so we know we've got a positive y-intercept, and it's sloping downwards. So it's going to look something like this. There we go, and if we label that, we've got y equals minus 3x plus c, And again, we'll have a look at the intercepts in a second. It does say in the question though only where it crosses the y-axis, and at the moment we only know that as being that constant c, so we'll label that as that. For the second one there, we've got a reciprocal graph and it's got a plus 5 at the end. So it's going to be the same as all the other ones we've drawn, except it's going to move up by 5. Very similar to the last one that moved down by 5, but this time it's moving up. So it's going to go something like that and something like that. And there we go, and it's moved up 5. Now for that particular graph there, again, that's not moved left and right, it's moved up, so it's not going to cross through the y-axis, but we have been asked here to write the equation of any horizontal asymptote. So if we draw the horizontal one going through, and let's just swap to this colour here, and we draw that through, there we go, that is going to be y equals 5. Okay, obviously it would have been y equals 0 before, but as it's moved up by 5, it's now y equals 5. So there we go, there's our two graphs, there's our sketches done. Now let's have a look at the next part. So it says, given that the straight line there meets the curve at two distinct points, show that 5 minus c squared is bigger than 12. Now that should be okay. If we set them equal to each other like we normally do, hopefully we'll get a quadratic, and then we'll be able to look at the discriminant here in terms of two distinct real points. Remembering that the discriminant when in there are two distinct real points means that b squared minus 4ac is going to be bigger than 0. Okay, that's where that bigger than 12 is kind of coming in the next part. So let's have a look at this. So let's set them equal to each other. So if we do that, we get 1 over x plus 5 is equal to minus 3x plus c. Now if we make this all equal 0, let's move everything to the left hand side maybe, or we could actually just go ahead and get rid of these fractions as well. So let's get rid of the fraction actually before moving anything. Doesn't really matter which order we do it in, but let's just go with that. So if I just times everything by x to start with, that'll give us 1 plus, and then everything's getting times by x, so 5x equals negative 3x squared plus xc or cx, whichever way you want to write that round. Right, adding that 3x squared to the other side then and minusing the cx, let's see what we get. I'm going to write the 3x squared at the start, so we get 3x squared, and then we've got the 5x, so plus 5x, minus the cx that we're going to move over, and then plus the one that we already have over there, and that all equals 0. So now we have a quadratic that we can look at, okay? Now we've got two pieces with an x in, so what we're going to do is we're going to have a look at, if we were to factorise out x, what would that coefficient of x be? And if we take x out, let's have a look, we'd get 3x squared, and we would get plus x lots of 5 minus c. Okay, all I did in that bit there was just looked at these two here and just factorised x out, and then we have the plus 1 at the end, and that will equal 0. So from there we've got our pieces, and you can kind of see that 5 minus c, which was coming in the question up here, and you can see where that's going to come from now. So we know we're on the right sort of track. So let's have a look at how we're actually going to get that being bigger than 12. So we have our coefficients of x squared, x, and our c at the end, which is our 1. We just need to put that into b squared minus 4ac. Now what I'm going to do is I'm just going to get rid of these diagrams now, so we've got a bit more space. So let's get rid of that. There we go. And get rid of all of that. There we are. So for our quadratic, we have a is 3, the number in front of x squared. B is equal to that bracket there, 5 minus c. And c is equal to 1. And if we put that into b squared minus 4ac, we get 5 minus c squared minus 4 lots of a times c. 4 times a, well a is 3, so that's 12, times c, which is 1, so it's minus 12. And all of that is greater than 0, as it has two distinct points, the discriminant is bigger than 0. Now all we need to do to finish this off is add 12 to the other side, and as you can see, we get 5 minus c squared is bigger than positive 12. And there we go, we've shown that. Now for the last part here, we've got hence find the range of possible values for c. So in terms of actually figuring that out, all we need to do is solve this as a normal quadratic inequality, where we're looking at something bigger than 0. Okay, not forgetting that this equation here, we're looking at where it's bigger than 0. So let's just get rid of all this work and we'll finish off this last bit to finish this off. There we go. Right. So not forgetting again, when we're looking at a quadratic, obviously I don't know whether these are going to be positive and negative just yet, But if we imagine what a quadratic looks like, okay, we're looking at the bit where it is bigger than 0, so we're looking for two solutions here. We're going to have when x is less than whatever that smaller solution is, and when x is bigger than, sorry, it's c in this question, so when c is less than that smaller solution and when c is greater than that larger solution. Okay, not forgetting quadratic inequalities, another video that I'll link in the description to make sure that you've had a look at. Now let's go about solving it then. So this is what we're going to solve. Okay, and for the purpose of solving it, I'm just going to set it equal to 12 for our solution. So 5 minus c squared equals 12, and let's get our solutions. So in order to solve this, we need to square root both sides. Okay, that's going to get rid of that squared bracket. And that would give us 5 minus c is equal to the square root of 12, but also not forgetting that's positive and negative root 12. Really important there not to forget that. So then we can obviously just rearrange this to find c. Now it doesn't matter what we do, we can just add the c to the other side and then add a minus the root 12 over. So if we do that, and if I do that in the same step, we would get 5 plus and minus root 12. When we bring those over, it's going to equal c, or positive c. And that gives us our two solutions there. We have c is going to equal 5 plus root 12, and c is also going to equal 5 minus root 12. And you don't need to worry about simplifying the third there, although you can do if you want. You can write root 12 as 2 root 3, as it's root 4 times root 3. We can actually simplify it if we want, but we don't need to. It doesn't say anything about having to simplify our answers. Now if we label those on the diagram, we know the larger one there is going to be the 5 plus root 12, and the smaller solution there is going to be the 5 minus the root 12. There we go, and there's our two solutions thinking about the quadratic. So in terms of giving our actual answer here, we know that c has to be greater than the 5 plus root 12, and for the final one, c has to be less than the 5 minus root 12. There we go, and there are our two solutions. They are the range of possible values for c. c has to be either greater than 5 plus root 12, or it has to be less than 5 minus root 12. Okay, and obviously thinking about the context of the question here, you can always type these numbers into your calculator. We've got 5 plus root 12, which comes out at 8.46, and 5 minus root 12, which comes out as 1.535. And again, thinking about the kind of concept of the question here in that diagram from before, it would be unlikely that it would be less than the 1.535, as obviously it had to be a positive constant, okay, and that's going to be really important here. So in terms of the fact that it has to be a positive constant, we can't have all the values that are less than 5 minus root 12, because there has to be a cut-off point there, as it has to be a positive constant. So that one inequality there isn't quite right at the moment. Now the fact that it can be bigger than 5 plus root 12 is absolutely fine, but there has to be a limit with this second one, so we have to just slightly amend that inequality just to make sure it takes that fact into account. And that means that rather than writing it can be any value less than 5 minus root 12, we're going to put it in an inequality that just says it's going to be between 5 minus root 12 and 0, but it has to be bigger than 0, okay, so we're not going to put an equal to sign on that, as that would mean it's not going to be a positive constant anymore. So there's our two solutions. C has to be bigger than 5 plus root 12, and it also then could be between 0 and 5 minus root 12. And there's our final answer for that question. Quite a large question there. Obviously we had drawing a reciprocal graph, drawing a straight line graph, drawing asymptotes, we had solving them simultaneously to find the coordinates, subbing them back in, we had quadratic inequalities, and what else did we have there? The discriminant. Tons of topics in that question. Again, I will link them all in the description, so if you're not, if you haven't revised or looked at the discriminant in a while, have a look at that. If you were unsure on the quadratic inequalities, then obviously have a look at that, but I'll put them all in the description below. But as for that, we have finished this video. Hope you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.